Certain metals can be extracted from their ores. For example, iron is extracted from hematite in a blast furnace, and copper can be extracted from malachite. The process of extracting metals from their ores can be time-consuming, costly, and harmful to the environment. Other less reactive metals, such as gold and platinum, can be found naturally as native metal. The issue here is that there is a finite or limited supply of these metals on Earth. In this lesson, we will learn about recycling metals and the advantages and disadvantages to these industrial processes. Aluminum is the most commonly recycled metal. Aluminum is used to make soft drink cans, aluminum foil, certain food cans, and even certain packaging materials. Aluminum is also used to make the outer bodies of some cars and airplanes, due to the fact that it is less dense than steel. The extraction of aluminum from its ore is done by electrolysis. It may not seem like a lot of electrical energy is needed, but keep in mind that this is done on an industrial scale worldwide. The recycling of aluminum uses only 5% of the energy used in its extraction from its ore, which uses a small voltage but a large current. In fact, some countries really encourage recycling by having separate sections in their public waste containers, one for waste, one for cans and other metal products, and another for paper products. Some countries also have mandatory household recycling, in a sense that if aluminum cans are found in regular waste bins for pickup, a fine can be issued. In fact, recycling aluminum is so common that any aluminum material that you encounter today has some, if not more, than 50% recycled aluminum content. Steel can be recycled, and most steel mills primarily use recycled scrap steel instead of cast or pig iron from blast furnaces. Copper is also recycled. Once again, this is a more energy-efficient process than the extraction from its ore. As well, the copper ore supply on Earth is being depleted at a very fast rate. As a result, other methods for the extraction of copper, such as phytomining and bioleaching, are being used instead. Silver and gold from jewelry are also recycled. As these metals are found as native metals, the issue here is not the energy cost, but rather the rarity of these metals. The main source of gold is recycled electronic goods, such as computers, which have their electrical contacts plated with gold, so there is no corrosion and a perfect electrical connection. The main issue with recycling metals is the separation process in the waste containers. Most often, not all metal products are clearly labeled as recyclable. As well, many metal products are alloys. Can you remember what an alloy is? Please pause the lesson and continue when you are ready. An alloy is a mixture of two or more elements, with at least one of the elements in the mixture as a metal. Many metal products are made into alloys for increased strength and other desirable properties, but not all alloys can be recycled, such as manganese-aluminum alloys. Some alloys, which can be recycled, need to be molten and separated into their constituent metals, thereby making it a more energy-costly process. As well, we have to take into consideration the fact that these metal products must first be collected and then transported to recycling facilities. All depending on the distances covered, this could involve quite a bit of fuel usage, and therefore increasing CO2 and noxious gas emissions. In summary, aluminum, steel, and copper are the most commonly recycled metals, and the recycling process usually uses significantly less energy than extraction from their ores.
A common definition is that recycling is a process which allows waste materials to be turned into new products and prevents the waste of potentially useful materials. Recycling reduces the use of fresh materials. It acts to reduce energy usage, reduces air pollution from incineration, reduces water pollution from landfilling by reducing the need for conventional waste disposal, and has lower greenhouse gas emissions as compared to fresh material production. So with all of these benefits, you must be wondering if there are any limits to a process that can have such a positive effect on the environment. Limits to recycling are often considered in terms of energy, hazards, costs, and practices by individuals and countries. The biggest limit to recycling, however, is that not all materials can be recycled, or can only be recycled a number of times before they lose their quality. Some materials, once used, are always going to have to be dumped, as we have no method for making them useful again. What sorts of materials do you think can be recycled? See if you can come up with 5. Pause the video and continue when ready. Commonly, these are the materials that are recycled: glass, paper, metal, plastic, textile, and electronics. How many did you get? Now, let's consider the different limitations. First up is the energy aspect. Put simply, some materials like paper and aluminium metal are agreed to have lower processing costs when it comes to recycling them, rather than using fresh materials to make new products. However, the recycling of materials like plastics is extremely energy intensive. Before the plastics can be melted and mixed together, they require sorting, usually by hand, as there are many different types of plastics, usually indicated by special marking and number. If a mixture of plastic is recycled together, they either contaminate the melt, or you get a lower grade of plastic than the originals, which is therefore less valuable. This reduction in the quality of a recycling product is called downcycling. In addition to this, there is the added complication that devices often use mixed materials. Think of a car. There are a wide range of recyclable materials: the copper wire, the aluminium in the engine, some of the plastics, the glass, and the iron. However, what about the alloys? These are mixtures of metals. Energy will be needed to separate these, and so one of the most difficult problems of recycling is the separation of randomly intermixed particles. Secondly, there are hazards to recycling, including the recycling of dangerous metals. Can you think of any dangerous metals? Pause the video and name some. Continue when you are ready. Some of the metals associated with recycling are lead and mercury. Often these metals can come from the recycling of waste electrical and electronic equipment. In India and China, a significant amount of pollution is generated where informal recycling in an underground economy of these countries has generated an environmental and health disaster. High levels of lead, polybrominated diphenyl ethers, polychlorinated dioxins and furans, as well as polybrominated dioxins, have become concentrated in the air, bottom ash, dust, soil, water and sediments in areas surrounding these underground recycling sites. Many of these chemicals become dissolved in the water that we drink, called leachate. Also, plants can take up these chemicals, allowing toxic chemicals to enter the food chain. Finally, if the chemicals are airborne, there are problems with us inhaling them. There are also social issues connected to recycling. Whilst it may create jobs, they are often jobs with low wages and terrible working conditions in developing countries. In areas without many environmental regulations or worker protections, job like shipbreaking can result in deplorable conditions for both workers and the surrounding communities. Thirdly is a challenge for you. What do you think the cost of recycling depends on? Pause, think and continue when ready. A good answer might be that the costs of recycling depend on the efficiency of the recycling program. Governments or local authorities may not recycle because it's cheaper to use landfill. Also, consumers are encouraged to recycle, but this depends on people being involved in pre-sorting their recycling. Some countries or local governments impose charges when this is not done.